Okay, water is a bent molecule. You see this bond between the oxygen and the hydrogen? Okay, you see that bond? Is that a 50-50 bond? Is that equal sharing? Okay, I want to convince you, and I submit to you that it's not a 50-50 bond. Okay, oxygen is something that we call an electronegative atom. Okay, what does an electronegative atom mean? Okay, this bond with that oxygen is like a vacuum cleaner. Okay, it's going to pull, and pull on that bond. Okay, it's going to pull on this electron density. It's going to pull on this electron density. This is how we depict this. This is how we showcase that pulling, that vacuum cleaner. Okay? Okay, you draw an arrow, make sure the arrow has a tail. And oxygen is electronegative, so it's going to have a partial, okay, negative charge. Okay, that delta means partial. If that's partial negative, what will this hydrogen be? Remember, it's pulling. So what will this hydrogen be? Partial what? Okay, partial positive. This is delta. It's the Latin letter delta. Same thing on this end. Okay, what is that oxygen doing? It's pulling. Okay, on that electron density. It's pulling. Okay. That makes that partial negative. What will this hydrogen at the end be? Partial positive. Okay, what can a partial positive do? It can interact. Okay, what can it interact with? What do partial positives interact with? They interact with negatives, or they can interact with partial negatives. Okay, how about, let's say, we make this interact with a partial negative of another water molecule, right? Can it? It can. So it can interact, this partial positive can interact with a partial negative of a water molecule. Okay, what about this partial positive? What can it interact with? What can it interact with? Okay, it can interact with a partial negative. Let's make that partial negative a water molecule, another water molecule. Remember, this oxygen is pulling. What do you think this partial negative can interact with? Partial what? Partial positive. Partial positive of what? Okay, let's make it another water molecule. We can. Okay, any partial positive, but I'm going to make it another water molecule. So like that, we have an attraction, partial positive with partial negative. Okay, we'll highlight them. Okay, there's three. Okay, we can do a fourth. This can go on forever. Okay, all across three-dimensional space. All right, so this molecule is two things. Number one, it's polar. Okay, number one, it's polar. And number two, what can it also do? Okay, check this out here for a second. Okay. Right, we have O, H, and then an O. We have a hydrogen bond. Okay. We have an O, H, and an O. We have an O, H, and an O. Okay. Okay, what are the three things we look for if we want to know if something can hydrogen bond? Okay, what are the three things? We look for an OH, F, and an NH. Okay, not only is water polar, but water can hydrogen bond. Okay, this is what makes water, as I was alluding to before, one of the more, amazing substances, okay, on the planet, okay? Because it can be polar, which it is, okay, partial positive and partial negative, but it can hydrogen bond. It has that OH, which can hydrogen bond with another molecule that has an H, okay? So look here again, OHO, there's a hydrogen bond. Okay, OHO, there's a hydrogen bond. There's an OH, and then another molecule here, OHO. Okay, so hydrogen bonding. All right, the last 8 minutes or so, let's look at dimethyl ether, the ether. Okay, do you think it can hydrogen bond? What do you think? Yes or no? Okay, can dimethyl ether hydrogen bond? Can it hydrogen bond to itself? Just, water can hydrogen bond to itself. What can dimethyl ether do? Okay, let me ask you this. Is it polar or non-polar? This oxygen is going to pull this side, making it partial negative. This carbon is partial positive. What about the oxygen on the other side? It's going to pull, making it partial negative. This carbon is going to be partial positive. So is it polar or non-polar? Polar. Okay, the oxygen is pulling, but can it hydrogen bond? No. Okay, do you see an OH, NH, or F here? First of all, there's no F. Okay, there's no fluorine. Okay, see anything? So this is polar, but no hydrogen bond. So we have water, which is polar and has the additional capability of hydrogen bonding. We have dimethyl ether, which is polar, but does not have the capability of hydrogen bonding. Okay, but both are polar. Okay, again, OH, NH, and F. OH, NH, and F. Okay, let's go back to the very first page here. Okay. Let's look back at this table here. In terms of intermolecular forces, okay, what would the intermolecular force be with ethanol and another ethanol? What type of intermolecular force? Which one? Hydrogen bonding, very good. So the ethanol, okay, you see that OH? Ethanol can hydrogen bond to another ethanol. It can hydrogen bond to water. Okay, it can hydrogen bond. Okay, and it can hydrogen bond to itself. That is its main IMF, or intermolecular force. Okay, what about dimethyl ether? What is its main intermolecular force? Which one? Polar. Dipole, dipole, polar. Okay. By the way, polar also means dipole, dipole. Okay, this is called a dipole, just by the way. This is called a dipole. Okay, partial positive, partial negative. They call it a dipole moment. Okay, for those that are going to take more chemistry later on. Okay, polar molecule, partial positive, partial negative. It means it has a dipole moment. So this is hydrogen bonding and polar, which has a dipole moment. This is polar, has a dipole moment, but cannot hydrogen bond. So why do you think the boiling point of one is so much higher than the other? It's the hydrogen bonding. Okay? Very same molecule, same number of carbons, same number of hydrogens, same number of oxygens, same molecular weight. It's just that one can hydrogen bond with the other. One can hydrogen bond with the other ethanol. This cannot hydrogen bond. There's still an attraction, but it's just a polar attraction. Right, so that's the difference, okay? This is a strong intermolecular force, the hydrogen bond. Okay, it's so strong that they actually have a book dedicated to it. Okay? A book called The Hydrogen Bond. Okay? It's some nice reading. So if you don't know about the hydrogen bond, I'll give you this book to read. All right, it is about I'm not including the bibliography here. 386 pages. If you include the bibliography, about 440 pages. Okay, a book dedicated to the hydrogen bond. Okay, so this is a very, very important intermolecular force. Okay, you can see all the hydrogen bonds here. Oh, this is a nice, hey, look at this. OHO. Okay? OHO. Let's see if I can find another one here. Okay. HO, and then there's an H here. Okay? So hydrogen bonds are very important in, here we go. OHO. Okay, that is a very, very strong attractive force. Okay, you're going to look for what three things? OH, NH, and F. Okay. Okay, finally, why do you think ethanol and water mix together? Why are they miscible? What is water? Okay, it's polar and it can hydrogen bond. What about ethanol? It's polar and it can hydrogen bond. Like. Okay, like dissolves like. This is why they are miscible. Okay, this is polar, can hydrogen bond. Okay, this is polar, can hydrogen bond. This is why they come together like this. Okay, like dissolves like. Okay, so the two intermolecular forces we learned today are hydrogen bonding and, actually three. What are the three that we learned? Ionic, very good, which is very strong. Think of lattice, metal and non-metal, full exchange of electrons. Okay, and what are the two polar ones? One is hydrogen bond, and the other one is polar, dipole-dipole. Okay. I should say under polar, what are the two categories? Hydrogen bonding and normal polar. Okay, normal polar.